In this video, we're going to take a look at practice quiz for standard 5. For number 1, it says to multiply x plus 4 squared times x minus 2. So what I'm going to do first is take the x plus 4 squared, and I am going to, let's use the box method. We're going to FOIL x plus 4 times x plus 4. And if you use a different method to FOIL, that would be fine as well. You should get the same thing. So I get x times x is x squared, 4 times x is 4x, 4 times x is 4x again, and 4 times 4 is 16. Then I need to add these two together. So I get x squared plus 8x plus 16. But then I've got to multiply that by the x minus 2. So if we say x squared plus 8x plus 16, we can make a bigger box. And we can put that on one side of the box, the longer side. So it's like a 2x3 box now. And then put the x minus 2 that you need to multiply by on the other side. And then just use the box in a bigger way. So we have x times x squared would be x cubed. X times 8x would be 8x squared. And x times 16 is 16x. In the next row, we have negative 2 times x squared would be negative 2x squared. Negative 2 times 8x is negative 16x, and negative 2 times 16 is negative 32. And then the ones that are diagonal from another usually add up. So let's say x cubed, negative 2 plus 8 would be 6x squared. They're like terms, so you keep x squared. You just have to add up the coefficients. And then negative 16x plus 16x would cancel out, because there's a negative and a positive of the same thing. And then I bring down negative 32. So then that would be my answer for number 1. Number 2 says to divide. Is 3x minus 2 a factor of the polynomial? So since there's a 3 there, I'm going to go ahead and use long division, so I don't have to worry about dividing by that 3. If you did choose to use synthetic division, you would need to divide everything by 3 first. And just make sure you would get the same answer that I get with long division. So I'm going to say 3x times what would give me 6x cubed. So that would be 2x squared. I'm going to write that at the top. Multiply it by what's out front and then bring those terms down. So I have 2x squared times 3x would give me back 6x cubed. And 2x squared times negative 2 would be negative 4x squared. And then you want to make sure you subtract both of those terms, so change the sign for both of them, and then bring down what you have left. So I have negative 25 plus 4 would be negative 21x squared. I'm going to bring down the positive 2x, and my process starts over again. So I've got to say 3x times what would give me negative 21x squared, which would be negative 7x. So I'll put that at the top. Multiply it by the two terms out front and bring them down. So negative 7x times 3x is negative 21x squared, and negative 7x times negative 2 is positive 14x. And then make sure you subtract both of those so they change signs. Those first two should cancel out. Then you bring down what you have left. So you have 2x minus 14x is negative 12x. Then you still have this plus 8. Then the process starts over again. So you want to think about 3x times what would give you negative 12x, which would be negative 4. You multiply it by what's out front and bring those two terms down. So negative 4 times 3x is negative 12x, and negative 4 times negative 2 is positive 8. Then you want to make sure you subtract both, so I change the sign of both of those. And they both cancel out, and then I had no remainder. So it says check 1, yes, 3x minus 2 is a factor, or no, 3x minus 2 is not a factor. So since I ended up with no remainder, then I would say that yes, 3x minus 2 is a factor. Notice this question says to divide. It's a little word, but it means you have to show that you divided this problem, and you did get a quotient of 2x squared minus 7x minus 4. If you don't do the division part and you just answer the question, is it a factor or not a factor, you would not get credit for this question because it's really a two-part question. It says divide, and then answer, is the 3x minus 2 a factor? So make sure on your quiz you do both of those things to the best of your ability. All right, and number 3 says find the remainder, use the factor theorem to determine if x plus 4 is a factor. So there's actually a couple ways to do this problem. You can take x plus 4 and do synthetic division. You can also plug in x equals negative 4 and figure out what the remainder is from there. So I'm going to do synthetic division. So negative 4 is in my box, and then I have 3. There's a 1, a negative 2, another 1, and a 12. Bring down the 3 to get started. So 3 times negative 4 is negative 12. 1 plus negative 12 is negative 11. Negative 11 times negative 4 is positive 44. Negative 2 plus 44 is 42. 42 times negative 4 would be negative 168. And then 1 plus negative 168 is negative 167. And then negative 167 times negative 4, let's see what that would be. This looks like we're not going to have a factor though, because these numbers are really big. So we get 668, and then you got to add 12. So that would be 680. Woo! So that would definitely not be a factor. So I'm going to leave that there for just a minute. Let's see if it'll, let's see. We'll just bring it back. So not a factor. If you plugged in x equals negative 4, so we have 3 times negative 4 to the 4th power plus negative 4 cubed minus 2 times negative 4 squared plus negative 4 plus 12. I would make sure you put it all in parentheses to make sure it calculates it correctly. All right, so we could check and see if that would also give us the same answer. So 3 times negative 4 to the 4th power plus negative 4 to the 3rd power minus 2 times negative 4 squared plus negative 4 plus 12. So notice you still get the same thing that way. So both methods would work. It just depends on which one you're more comfortable with. But either way, you get a remainder of 680. So notice in this question it says to find the remainder. So you do need to actually say what the remainder is. And then also use the theorem to determine whether x plus 4 is a factor. So that just means if you come up with no remainder, it would be a factor. But we had a remainder of 680, so it is not a factor. All right, let's move on to number 4. It says find all the zeros of f of x equals x cubed minus 6x squared plus 13x minus 10, given one factor of the polynomial is x minus 2. So if I take x minus 2, the root of that would be x equals 2, and you want to do synthetic division to help you reduce this to something quadratic. So I'm going to put 1, negative 6, 13, and negative 10. Bring down the 1 to get started. 1 times 2 is 2. Negative 6 plus 2 is negative 4. Negative 4 times 2 is negative 8. 13 plus negative 8 is 5. And 5 times 2 is 10. So you should have a 0 there like we've talked about. And then you have your x squared minus 4x plus 5. So you want to plug this into the quadratic formula. So we would say, since ax squared plus bx plus c is our standard quadratic form, a equals 1, b equals negative 4, and c would equal 5. And then you just want to plug all that into your quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. We will not give you that formula, so please come prepared to know the formula by heart. So let's put x equals negative b, so negative 4 plus or minus the square root of b squared, so negative 4 squared minus 4 times a, which was 1, and c, which is 5, all divided by 2a, which was 1. And then you just need to clean that up. So negative 4 would be positive 4, plus or minus the square root. And you could say negative 4 squared is 16, and then 4 times 1 times 5 is 20. So 16 minus 20 is negative 4. And then 2 times 1 is 2. So first you want to reduce this radical before you divide by anything. So let's put x equals 4 plus or minus, and then the square root of negative 4 is equal to the square root of negative 1 times the square root of 4, which would just be 2i. And then it's all still divided by 2. So you would just be able to divide in that very last step is the only place you want to divide. And you would get that they all could divide evenly by 2. So it'd be 2 plus or minus I. And then I think we didn't put a place there for your roots. So let's just put them all together now. So x equals, the root that you started with was the 2. And now you have the other 2 because we needed 3 all together. And so that would be your final answer for number 4. So you've got to do synthetic division and then quadratic formula to get your 3 roots. For number 5, we're going to have 2 separate versions, one for standard and one for honors. So for standard, you have a cubic function. And if you're in honors, you can fast forward this video to get to your problem. But for standard, you'd want to type this in. And also for honors, they're going to do the same for their first step. So if honors is watching still, this would still help you review. So you're going to type this in. And then I noticed that I have a double root at negative 4. So you don't have to solve this problem the same way we did number 4. We can tell there are 3 total roots. And by looking at the graph, you can see that negative 4 is a double root. And then 3 is the other root. So those are your 3 roots. So x equals negative 4 and x equals 3, and negative 4 was a double root. So you actually have 3 real roots, negative 4, and 3. Or you could write negative 4 is a double root, and the other one is 3. And then imaginary roots, there are none, so we could just put like NA or none, or just leave it blank. All right, so for honors, we'd want to do the same process. Type it in your calculator and check and see what's happening. So let's say x to the 4th, or I would type it in Desmos. It's just easier to manipulate the graph with Desmos for these. So just, hold on, let me delete that. Okay, so type it carefully in your calculator, and then you can tell you have 2 real roots, and 2 would be imaginary. And we know we have 4 total. So if we have 4 total roots, 2 are real, which are 1. So let's say 2 real roots are 1 and 3. And then we must have 2 that are imaginary, and we need to find those roots. And so what you do is take those 2 real roots, 1 and 3, and you pick one of those to start with. It doesn't matter which one. So I'm just going to pick the 1. Now I need to do synthetic division twice so that I can reduce this quartic polynomial. It has a degree of 4 into something quadratic. So you just have to do synthetic division twice. All right, so we know we should end up with a 0. So I'm going to go ahead and put that down there. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. 7 plus negative 3 is 4. 4 times 1 is 4. We get negative 12, and they add up to 0. So what you have here is a cubic polynomial. We need to reduce it one more time to be quadratic. So since I used the 1 already, I'm going to need to use the 3 next. Then you want to bring down these coefficients that are your new coefficients of your cubic polynomial so that you end up with something quadratic in just a minute. So bring down the 1, we get 3, 0, 0, 4, 12, and then we end up with 0, which is what we want. So now we have a quadratic function. So we put x squared plus 0x plus 4. Now, you can put that in the quadratic formula. You can say that's a equals 1, b equals 0, and c equals 4. That is definitely one way to do it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We do expect that you know that formula, so study that if you need to. And then we can put in our b. So negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 4 all over 2 times 1. So you would get 0 plus or minus, and inside there you have 0 minus 16, which is negative 16. And then you end up with 0, which doesn't really do anything, but plus or minus 4i over 2, which would reduce a little bit to be plus or minus 2i. So the other way you could have solved this is just by the square root method. So if you notice, you have x squared plus 4. If you take out the 0x, you could actually just set that equal to 0 and say x squared, and then you can subtract the 4. So x squared equals negative 4. Let me write that a little better. So let's subtract the 4. So we get x squared equals negative 4. And then if you take the square root of both sides, you would have to put plus or minus 2i. So if you like that method, it's a little quicker. Quadratic formula works to give you the same answer. And then in the end, you just want to put all of that together. So you had 2 real roots you started with. That was 1 and 3. And now you have 2i and negative 2i. Or you could write 1 and 3 and plus or minus 2i. So either one of those answers would be fine. At the bottom, you'd want to put those in the right spot. And so you would put over here for your real roots, you had 2 of them, 1 and 3. And if you want to put x equals 1 and 3, that would be fine. And your imaginary roots would have been the plus or minus 2i. You can write them separately. You could put x equals. Those would all be okay. All right, so that is it for practice quiz number 5.